Welcome to another Too Tall Toby exercise or practice model performed in IronCAD. This is a actual sheet metal part, so we're going to go ahead and show you how we do this in IronCAD's sheet metal design using our handle-based modification on our sheet metal. Some key things: we know the overall height and length on this part. We do know some critical information that this height is 12 millimeters down for where our center needs to be, and that this is also 60 millimeters from the top. So this one we have to figure out how to do that calculation, which I'll show you. And then we have the rest of the geometry just has just additional spacing here and some shapes that we need to do for our slot features. We do know a default thickness is 4 millimeter and our radius is 4 millimeters. So let's go ahead and hop over to IronCAD and we'll show you how this is done. So in IronCAD we have our standard starter catalog, and there's a sheet metal folder inside of there that you can double click on or drag and drop the folder out to use. You can also go to more catalog and sheet metal if you like to use that catalog. They're the same ones, but either one will work. So we're just going to use our default starter catalog and hop into here, and I'm going to drag and drop a stock out, and it doesn't really matter what I select here since I'm in imperial units. This is going to be the wrong stock table. I can put a different stock table in there with the right values, but either way we're in millimeters, so we're going to go ahead and just go to the part properties of this guy and set it to 4 millimeter thickness and 4 millimeter minimum bend radius. So that gives us our default settings. Now we know that overall length of this is 146 and 170, so we can just type in those two values to get that. And next we can go over to our shapes catalog or hit back and go back into our starter catalog, but we can go over to our shapes catalog to grab over a cut shape. So we can mix and match sheet metal and regular shapes. So we're just going to line this to these two edges here. And we know that this, when we line this here, has a value of 146 minus 40, so it's a 40 millimeter offset. And this bottom side, so again, so we know from here to the top, it's got to be minus 60 on that is where the bend needs to be. But we also had to add on 12 millimeters for where our center cut is. So we're just going to go ahead and take that value again and just add 12 to that. So that gives us the location for that starting geometry. So let's go ahead and start on this area here. And we'll go back to our shape metal and drag and drop a bend shape, and we can drop on either edge. If you drop on this back edge, it'll go away from us. This one will come in front of us, but there's always an arrow here that you can toggle that. So either way is fine. So we can just move that over, and what we know is the width of this needs to minus that width of our hole, which is 16 diameter there. So we'll go ahead and get that offset. And we know this has a value here. If you double click on it, you can see how it's currently I have mine set up to do outer sharp. So I can type in the value there to be exact, which is, let me double check that. I gotta find that 35 for that value. So we'll go ahead and move that 35 from there. Now we need to move this to 16. So if we look at this distance, just to show you, we have two handles. We have our feature handles, which modify just the feature itself, or a part handle actually can move the bend and the stock. So one of the things we can do here is right click on that and say add a distance from point. And we can see by default it's 56 because we moved it down 12. So this handle allows us to move the stock, which we need to be at 60 from that top face. So it'll actually move this bend up and add stock to it. So it gives us that extra material that we need there. So next we can go ahead and drop our shape. Again, we can hop over to our other catalog, type in our value of 16 for that, and use the TriBall. I'm just going to position it right there on that center point of that edge to get us in the exact location. So that gives us our cut there. So that is a very easy way to do that in IronCAD. Again, we don't have to do any cross sections on that. Last, we'll go ahead and put this oboe round on here, or we call it oboe round in here, but it's actually just a slot feature. I can just drag and drop that out here, and I'm going to use the TriBall. I'm just going to turn it around 90 degrees here, and then we can right click on this little arrow here and go to tooling properties. So we know the value of this slot feature is got a total of, let's see, 28 plus 12. So we go ahead and that's going to be 40 for that, and it's going to be 12 for the width. We can go ahead and type that in, and then we can use the TriBall to position this. And we know all the dimensions are from the center point of this side. So I'm just going to hit the space bar, hold the center point and my shift key to get to that center point there. And I can hit my space bar again. Now I'm on that center point of that, and now I can use that as a reference. Instead of using dimensions, I can just use the TriBall to drive this. So I know it needs to be a value of 15 millimeters from that, and it needs to be a value down. I could use the planes to do this as well, but we'll just use two handles here and do 13 for that. So that gives us our positioning for that shape. Next, we'll do our bend up here. So we'll go ahead and drag and drop a bend. Again, I can drop on this side to get that to move out that direction, and we know that this has a value of 55. So we'll just double click on that, type a 55 for that. And we know this value here is going to be 140. Again, it's from our virtual sharp here. So we know it's a value of 140. Let me double check that. Yeah, 140 for that. Okay, next we need to drop again that same shape in there. So we'll scroll down our catalog. We got that oboe round. I'm just gonna drop it in the center. It doesn't really matter. Again, I'm gonna rotate it around here. Let's rotate it around 90 degrees. And again, we can go into these tooling properties. And in this case, it's going to be a 25 for that and 20 width for that. So that's a simple way to do that inside of there. And oops, I forgot to apply that. There we go. To apply that. Now we can do the same positioning in here. It's got the same reference location again from the center point of this top arc. So we'll use the TriBall again, do that same process, hold the shift key down, put it there, move it over to the corner. And to do this, again, you can do that with handles or you can do it with this plane so we know it needs to go over and down. So we can type in those values. We need to say move here. That value again is 30 from the top edge, and distance one is actually the down one. So the down one is actually 25. The distance 2 is 30. There we go. So again, so that's just to give you an idea how to position that using those dimensions. But again, if you want to check it, you can always right click on this, edit distance from point. There, that gives you the 30. The other one will be 25. So just to give you an idea. And then we want to make a copy from here. We're just going to right click and drag, make a linked copy of that, and that has a value of 60 from the center. A simple way to do that. So now we've got those two shapes. I've got everything on here. The last thing we need to do is all the edges need to have a blend on them or a corner break. So we need to select our corner break tool in the sheet metal, select our part, and we want that to be 8 millimeters. Double check that. You see, yeah, radius of 8 for all the places there, and hit OK, and that will apply it to all corners for us. And now we can look at our part. It has a mass density in this case of 7,800, and that gives you 681.1 for our mass inside of there. And you can also unfold this if you like. Just right click on the sheet metal part and hit unfold. That will give you your flat pattern that you can see inside of there, and we can fold that back up just by right clicking again. You can also access that by hitting your S key on your part. They're sitting right here, the fold and unfold, so you can unfold it, hit your S key, fold it back up. So there you go. That's a simple way to build this one in IronCAD sheet metal design using the handles. We use handles on our regular shapes, which, for example, that cut shape there, and we also use the bend part handles and feature handles to drive and modify this geometry. Hopefully you found this one useful.